For thousands of years, humanity has been haunted by one question. How did life really begin on Earth? Was it a divine spark that breathed life into lifeless matter? Or did life come from the stars, riding aboard ancient comets that crashed into our young planet? These questions are not only fascinating but also deeply personal, because without their answers, we cannot fully understand who we are and where we truly come from. To begin unraveling this mystery, we must travel back in time, about 4 billion years ago when Earth was a violent alien world. The skies were filled with meteors, the oceans boiled with volcanic heat, and lightning storms raged endlessly. This was the backdrop against which the first whispers of life appeared. But here's the shocking part. Scientists now believe that the ingredients for life might not have been born here at all. Instead, they may have been delivered from space itself. Meteorites like the famous Murchison meteorite discovered in Australia in 1969 contained more than 70 different amino acids, the very building blocks of proteins. And with modern telescopes like ALMA, we've detected complex organic molecules floating in the vast clouds of interstellar space. In fact, sugar molecules, alcohol, and even precursors to DNA have been found drifting between the stars. It's as if the universe is a massive chemical warehouse, stocked with everything needed to build life. But raw ingredients are not enough. The real puzzle is, how did lifeless molecules organize themselves into something that could grow, replicate, and evolve? In 1953, Stanley Miller and Harold Urey performed a groundbreaking experiment. By simulating Earth's early conditions, water vapor, methane, ammonia, and electrical sparks, they showed that amino acids could form naturally. This proved that life's chemistry could arise from the chaos of a young Earth. But here's the catch. Amino acids are like letters. You still need grammar, structure, and meaning to form sentences. So how did these random molecules assemble into the first living cell? Many scientists point to RNA as the missing link. Unlike DNA, RNA is simpler and capable of both storing information and replicating itself. This gave rise to the RNA world hypothesis. Recent experiments have shown that, under the right conditions, RNA molecules can spontaneously form short chains and even begin copying themselves. Imagine tiny strands of RNA, trapped inside protective bubbles of fat molecules, floating in the ancient oceans. These protocells were fragile, but they carried the spark of something new, the ability to evolve. But evolution requires energy, and this is where nature's creativity comes in. At the bottom of the oceans, near hydrothermal vents, scientists have discovered ecosystems that thrive without sunlight. These vents release mineral-rich boiling water, perfect conditions for driving chemical reactions. Some researchers now believe that life may have begun here, in the dark depths, where heat and chemistry created the first metabolic cycles. In fact, the common ancestor of all life, known as LUCA, the last universal common ancestor, may have lived near these hydrothermal vents around 3.7 billion years ago. LUCA wasn't the first living thing, but it was the ancestor of everything alive today: plants, animals, fungi, bacteria, and even us. Now here's a mind-bending twist. Not all scientists believe life started on Earth. The panspermia hypothesis suggests that microbes could have traveled here from Mars or even further. And this isn't pure science fiction, because we found bacteria on Earth that can survive the vacuum of space, intense radiation, and freezing temperatures. In 2020, Japanese scientists revived microbes that had been trapped inside rocks at the bottom of the ocean for over 100 million years. If life can endure such extremes here, why couldn't it survive a journey across the cosmos? And this leads to a bigger question. If life began so quickly on Earth, just a few 100 million years after the planet cooled, could it be common across the universe? Astronomers using the James Webb Space Telescope are already scanning distant exoplanets for biosignatures, chemical fingerprints of life. If we find methane, oxygen, or other unusual chemical imbalances in alien atmospheres, could mean we are not alone. But before we look outward, we must face the truth about life's fragility here on Earth. The leap from simple cells to complex multicellular organisms was not guaranteed. It took nearly 2 billion years before single-celled life merged and cooperated to form more advanced creatures. Without this rare symbiosis, where one cell engulfed another to form mitochondria, evolution might have stalled forever. No plants, no animals, no humans. Just a microbial world. Think about that for a moment. Every heartbeat you feel, every breath you take is powered by mitochondria, tiny descendants of ancient bacteria living inside your cells. In a way, each of us is a walking partnership between different forms of life that came together billions of years ago. So, how did life really begin on Earth? Was it lightning striking a primordial soup? Deep-sea vents cooking molecules into cells? Or alien seeds carried across the stars? The truth is, we don't yet have a complete answer. But maybe that's what makes this mystery so beautiful. Because the search for life's origin isn't just about the past, it's about the future. The more we learn, the closer we come to answering the ultimate question. Are we a cosmic accident or a cosmic inevitability? And perhaps one day, when we finally discover life beyond Earth, we'll also discover something about ourselves, that life is not a miracle unique to this planet, but a natural outcome of the universe itself. Thank you for watching. If this journey through the mystery of life's origins fascinated you, let me know in the comments what you think. Did life start here on Earth, or do you believe it came from the stars?